This is a NEET 2020 question in electromagnetic waves. It says light with an average flux of 20. So whatever the word that he has used, look at the unit that was given for you, 20 watt per centimeter square. So what do you mean by watt? Actually, energy per unit time is power that is measured with watt. By centimeter square means area. So what is given for you is energy emitted by a body, light energy emitted by a body per unit surface area per unit time. Now the area is given for you. The energy received by the surface in a time is how much? So if you want energy, take this to other sides. AAT into 20 watt per centimeter square. Now area is given as 20 centimeter square. Time is 1 minute, that is 60 seconds, into 20 watt means joule per second. Now if you look at the units, this second and second will cancel. This 20 centimeter square is the area, and by centimeter square is there, of course. This one, these two also will cancel. So I need not make a conversion from centimeter square to meter square because given data is also in centimeter square. So what is remaining is 20 into 60 into 20 joules, that is 2 into 6 into 2, that is 24 into 10 power 3 joules. So answer B is the answer for that problem, for that simple problem, right? So that is just a given simple data substitution, right? Let's have a look at the next question. A parallel plate capacitor of capacity C equal to 20 microfarad is charged by a voltage source whose potential charging at a rate of 3 volts per second. That means charge of the capacitor dV with respect to time is 3 volt per second. dV by dt is given for you. Through a connecting wire, the displacement current through the plates would be respectively the displacement current and the conduction current. He wants the ratio of the conduction current through the capacitor, to the connecting wires, and the displacement current through the plates of the capacitor. You know, when we are talking about different parts of circuit, whatever the current passes through the wire, that is called conduction current, will automatically further pass to the capacitor, which is called as displacement current. So both are same. If I measure one current, automatically that is the answer for the other part also, right? So in fact, if you look that as the data, so 0 0, this could be probably one answer, but these two are definitely wrong because these two are equal. This could be one answer. We have to work out of that, but all other options are wrong because they are equal, they are unequal, right? Now look at the equation. As per the Maxwell's equation, the displacement current can be expressed as epsilon naught into d phi by dt, where epsilon naught is the electric flux developed. Phi is the electric flux developed. E dot A, like a magnetic field B dot A, this is equal to E dot A. So this can be written like epsilon naught A dE by dt, where E is electric field intensity between the plates of capacitor. But we know the relation V equal to ED, potential and the electric intensity relation between the plates of a capacitor. So E can be written like V by D. That implies displacement current is this equation, epsilon naught A d by dt of V by D. Here distance between the plates of a capacitor doesn't change with time, so it can be written outside, epsilon naught A by D dV by dt. Epsilon naught A by D is nothing but the capacity of a capacitor. So displacement current is capacity of a capacitor into dV by dt, the voltage flows through the capacitor per second. I know all of them. That implies displacement current is C is given for you as 20 microfarad, 20 into 10 power minus 6. dV by dt is given for you in the problem as see 3 volt per second, that was given here, 3 volt per second. So this becomes 60 into 10 power minus 6, that is 60 microamperes. That is even the other current, that is this is displacement current, that's also equal to the conduction current, because in a circuit both are same. First passes like a conduction current, then it becomes a displacement current. So 60 and 60 becomes the answer to our problem. That's how we solve this problem. Thank you for watching.